so here's a little introduction to what we're thinking about today. It says, Mrs. Cheryl is sick of using degrees. She's over it. I'm over it. They're so played out. We're going to see today what else we could measure angles with. Okay, so what we're going to do, so we're going to now take the wiki stick. We're going to move it off of the radius. Hold it in your hand. We know that it is representing the length of the radius. And then what I'd like you to do is stick the one end of the wiki stick right here where that radius line touches the edge of the circle. And then the wiki stick is really nice and bendable, just like my ruler is up here. So what I want you to do is bend that wiki stick, following the curve of the circle, and you can just leave it stuck to your paper. But then what I need you to do is grab your pencil and make a mark just like this. So let's mark that distance. How far did one radius wrap around the outside of the circle? And once you have made the mark, we can actually extend a line all the way to the center of the circle like this. All right, we are going to now put a label. We're going to give a name to this angle that we have just created. So I'd like you to draw in a little angle curve there in the middle. We're going to use theta again to represent a symbol for an angle. And the name for this angle we've just drawn is 1 radian. 1 radian. Now, just as we have different units of measurement for length, you can measure a length in inches, you can measure a length in centimeters, you can measure a length in miles. The size of those units are different from one another. A mile is a lot bigger than a centimeter, but they still measure the same thing, they still measure distance. And so that's what this is. In the world of measuring angles, we have degrees, that is one way to measure, and we also have radians. Now, what I'd like you to write on your paper down here below your circle, or even off to the side, we are going to write a definition, if we were to put this into a sentence, for what we've just done here, for what a radian is. So I'm going to write the word radian. And I want to say here, okay, what a radian is, this is the angle measure when the arc length, that is the curved part of the circle, is equal to the radius. And so what we could also label here in our picture is, let's put the name of radius next to that horizontal line that was already drawn on there for us. And then let's also put the label of what do we mean by the arc length. We mean this curved part there of the circle. And that's what we did with our wiki stick. We had our wiki stick on top of the radius. We put it on the curved part to make the radius equal to the arc length. The resulting angle is 1 radian. All right, so what we're going to do now is we're going to repeat the process. So I'd like you to unpeel your wiki stick from this position. So you have it in your hand, and we are going to measure another radius around our arc length. So what I'd like you to do now is start your wiki stick where the other one ended. Go ahead and curve that. Follow the curve of the circle. And again, I want you to draw a second line, make a little mark at however far over that goes, and then I want you to draw another line all the way down here to the center. Now, if we were to measure that second line all the way out to that second line that we drew, still from the same starting position, so thinking about standard position, we have now traveled 2 radians. So I'm going to actually label this one in a different color so that it stands out from the other. But this full angle here in red, that would now be 2 radians. So what I'd like you to do now, in your head, I want you to make a prediction. How many radians do you think there are in a full circle? Once you've thought about that, I want you to find it out. I want you to measure it. So continue using your little wiki stick radius length to go around the circle. Each stopping point, I want you to put a little mark so that we can keep track of where that was. And let's see how many times this fits all the way around. We're going to come back together. So some of you, I want you to try to measure this again. I know it looks like it's close to 6. Our prediction might have been that it was exactly 6, and so you might have already been thinking that. When I measured mine, it wasn't exactly 6. It's a little bit short. And so to have you believe me, I just want you to try this again. So even if you just start with this and kind of hold it on one, move it around, what I want you to see for yourself on paper in front of you, that we actually have this little extra. So I'm just going to highlight that little yellow part, like it did not fit exactly 6 times. So let's take a moment to just remeasure so you can also see there's a little gap. It doesn't quite fit exactly 6. Is really significant. It's really significant for us to understand how many radians are in a circle, to know that it's a little bit more than 6 radians. So let's first write off to the side here. I'm just going to say, okay, so it's a little more than 6 radians, 1 full distance around our circle. So we're going to see if we can work backward just a little bit to understand, okay, well, how many radians is it? And so if it's a little more than 6 radians, 1 full time around, what I'd like for us to think about is the halfway point. So from this horizontal radius line drawn in black that we had at the very start, if I were to extend that all the way to the other edge, kind of making it look like a diameter is 1 full time around the circle, I'm noticing that on the top half of the circle, it's not exactly 3 radians, which would make sense. I'm having that little gap again. It's not as big as the gap on the other side, but it's there. And so I just want to notice here that halfway, the top half of our circle, is a little more than 3 radians. What number could it be in the top half, knowing that it's just a little bit more than 3? Is there a special number you can think of that we sometimes use in the context of circles? It is pi. Close, yeah, you were thinking about degrees. Yeah, nice job, Josh. Yes, it is pi radians in the top half of the circle. So what is pi? Well, it's approximately 3.14. So that is that little more than 3 measure. So here's what I'd like you to write. So it's actually a number pi. So this is our pi symbol. If we were to write it out as a word, it's just spelled P-I, and it's approximately equal to 3.14. It's actually another irrational number. It's a never-ending, non-repeating decimal. It's like 3.14159. It just continues on and on. And so if that's half of our circle, then 1 full distance around is actually 2 pi. 2 times pi. We just write a 2 in front of the pi symbol. And if you multiply 3.14 by 2, it's approximately 6.28. So that's why we have that little bit of a gap there. So it's like 6 full radians, and then it's almost a third of another radian. That is technically 1 full trip around the circle. All right, so because the pi symbol is used here to help us understand the exact number of radians in half of a circle, in a full circle, The pi symbol is something that we use when we're labeling all of our unit circles in radians. So something that's going to help us to do that are two new circles that you have on the back side of your paper. So let's go ahead and turn over to page 14. Okay, so these two separate circles together, if we were to place one on top of the other, it would make all of the lines that match with our unit circle angle. But when we're first learning how to label these in radians, I like to think of the circles separate. So in this first circle here, so notice that it's divided into 8 sections overall. I have 4 sections on the top half. And let's start to think about our angles being measured again in standard position, where the initial side is along the positive x-axis. I'm going to actually draw in some lines just like this, so you're still thinking about this as a circle on top of an x and y axis. This is still x and this is still y. And so if I have my initial side here for standard position, and if I travel one full distance around my circle and end in the same place, I just went counterclockwise, so I'm going to get a positive angle measured. We saw that in terms of radians, it's 2 pi radians, one full trip around the circle. Now, another thing that we can do, we saw this when we did this with degrees, is that if our initial side and terminal side are in the same place, we haven't moved at all. Technically, that's going to be 0 radians. So next to the 2 pi, I'm just going to write a comma and put a 0. We just have 2 different ways that we can label that position. Another thing I want you to know is that radians don't have units. I mean, there's no symbol. There's no symbol for units. It's not like with degrees where we have the little degree symbol. So we don't put any sort of symbol after it. It's just the value. All right, let's think about going halfway around our circle. If we just travel the top half, we saw that it was a little more than 3 radians, and we decided that the exact value was pi. Okay, so using the fact that our top half is split into 4, we're now going to think about how we can label the rest of these positions. So starting here, if I only go 1/4 of the way, this is 1/4 of pi. Now, instead of writing 1/4 times pi, the way that we write it is pi divided by 4. So it just looks like a fraction, pi over 4. And that's the size of every sector, every piece in this circle. So every time I go that distance, I'm going another pi over 4 radians. So if I were to start down here and go all the way up to the top, I can see that I've traveled 2 of those sections. So I've gone 2 pi over 4 radians. I'll label it 2 pi over 4 here on the top. Now, what you'll notice when we are doing our labels today is that sometimes we have a fraction that can be simplified or reduced further. 2/4 is the same thing as 1/2. So this can really be written as pi over 2, which makes sense because it's halfway to the label of pi. It's halfway, half of pi. All right, however, thinking about it with a denominator of 4 is going to help us to get the next label. So we have 1 pi over 4, 2 pi over 4. Well, if we add another, we're going to get 3 pi over 4. So 3 pi over 4 is going to be our next label. And then what's interesting is that if we keep counting here to get to this left side label, it would be like 4 pi over 4. Well, that's not too surprising because 4 pi over 4, the 4's would cancel, and that would simplify down to pi. All right, so let's check in here on the bottom. So from 4 pi over 4, we continue with 5 pi over 4. At the very bottom of our circle, that would be 6 pi over 4. Sorry, all these little things keep showing up. 6 pi over 4 on the bottom. Well, just like the one at the very top, you can reduce that down. 6 over 4 is the same thing as 3 over 2. So it's really 3 pi over 2. But I'm going to think about it as 6 pi over 4 to get the next label of 7 pi over 4. If I kept going, I would have 8 pi over 4, but that simplifies down to be 2 pi. So that's also not super surprising. Now, the other thing to know is that there's no limit to the number of times that you go around your circle. Just as we saw with degrees, we can go multiple times. So let's say that we made one full trip and we're at 8 pi over 4. You can just keep counting. So this would be 9 pi over 4. This would be 10 pi over 4, or 5 pi over 2. This would be 11 pi over 4, and so on. You can keep going round and round. Now, what I'd like to do here is circle the key labels that we want to use moving forward. So like at the top here, 2 pi over 4, I like to think about that when I'm getting the rest of my labels, but we're actually going to write it as pi over 2. Same on the very bottom here, we're actually going to write that one as 3 pi over 2. Otherwise, the rest of them have a denominator of 4, unless it was like the far left side and the far right side, where it's just 0 or 1 pi or 2 pi. All right, now connecting this back to degrees, the pi over 4 family of angles, which is what we're looking at here, this is like our 45-degree reference angle triangle. So that's the one that it matches with if it was labeled in degrees. All right, so let's talk about this next circle here. So this is going to help us with the rest of our labels of our unit circle angles. I'm going to do the same thing here of extending these lines out, the horizontal and vertical lines, again, just to think of it as an x-axis and a y-axis. That's what this circle is sitting on top of. And we do already know some of the labels and radians. So to transfer some over from what we just did in the previous circle, we know this first position could be 0 radians or it could be 2 pi radians. The top of my circle still represents the halfway point, so that's still pi over 2. The far left label here is still pi, and the bottom of our circle is still 3 pi over 2. The only thing that's different now is the position of the other lines that are inside of our quadrants. Now when we look at, let's look at the first quadrant, this one is split into thirds rather than just being split in half. So what's going to help us with these labels is to look at how many sections it's split into for the entire top half of the circle. So we see that we have 6 sections on the way to pi. Well, if we just go up to one of those lines, that's 1/6 of the way to get to pi. So we're going to label this one as pi over 6. So that's going to be the size of each piece on this circle. So when we go to the next line, it's really 2 pi over 6. Which it looks like we have a position now that we could simplify. 2 pi over 6 is really the same thing as 1 pi over 3. So that's actually the more simplified one that we will use. Counting up by 2 pi over 6, the next one is actually 3 pi over 6. Not surprising, because that simplifies down to be 1 pi over 2. Continuing to think about counting up by pi over 6, I want you to go ahead and label the rest of the angles. If you're not able to simplify it, you can leave the denominator as 6, but otherwise, each one that you write out, think, okay, can this be simplified? And then I'd like you to reduce it down. All right, so let's check in here on our labels. So continuing where we left off, so we had 3 pi over 6 at the top, so the next one is going to be 4 pi over 6. Well, that's one that we can simplify, so that's going to be 2 pi over 3. 5 pi over 6, we can't simplify that, so we just leave it as it is. 6 pi over 6, not surprising, because that's the same thing as pi. Then moving into the third quadrant, we have 7 pi over 6. 8 pi over 6 is really 4 pi over 3. 9 pi over 6, that simplifies to 3 pi over 2. We already have that one labeled. 10 pi over 6 is 5 pi over 3. 11 pi over 6, keep it as it is. If we get back to where we started, it's 12 pi over 6, but that's really the same thing as 2 pi. So I'd like for us to go back again and let's put a box around the final angle label, the most simplified version for each position. The ones with a box around them, these are actually the ones that we will officially label on future versions of our unit circle. But thinking about the other fractions that we wrote off to the side, that's always helpful at the start to initially think about getting them labeled. All right, so what we're going to do now is we are going to fill in all of the angles measured in radians on our fancy cardstock unit circle that we did from a few days ago. So I already have the pieces here filled in. The angles are in degrees. We already have our X and Y coordinates filled in. You'll notice that there's another line that's right here. I'll highlight a few of them. There's another line kind of right next to where the degree label was, and we left that blank. What that was for was to put in the measure in radians. So let's see if we can fill these in. So starting at the very starting position here of our circle, we have two options again, two labels here. So it could be 0 radians or 2 pi radians. Now what we're thinking about here is putting these two separate circles that we just looked at, one on top of the other. If we were to do that, the first angle measure that we're going to get at is going to be from this bottom circle. So that 30 degrees, that is equivalent to pi over 6. That's our smallest angle in this first quadrant other than 0. Now, the next position we get to, that's going to be the label now from this top circle. So that's the halfway point. And so that 45-degree angle is pi over 4. And then the next position is going to go back down here to our bottom circle. So the last angle that we have before we get to the very top is pi over 3. Another way that we can think about the denominators in the labels here is that with a fraction, the larger our denominator, the smaller the piece is. If you have a pizza and you cut it into 100 pieces, those pieces are going to be a lot smaller than if you cut it into 5 pieces. 1/100th is smaller than 1/5. So the largest denominator is listed first here, that's the smallest angle. And then as the denominators get bigger, our angle is, as the denominators get smaller, our angle is getting bigger and bigger. All right, at the very top of our circle then, we saw this on both of these separate circles, that's pi over 2. And then now we're going to move into the second quadrant. So our next label here is going to be 2 pi over 3. Notice how 2 pi over 3 is the same height as 1 pi over 3. That's not a coincidence. They have the same reference angle. There's a connection in the XY values. The next one here is going to be, when we look at this top circle, that is our 3 pi over 4. Notice how 3 pi over 4 is the same height as 1 pi over 4. And the denominators were the same. And then the next one we have here is our 5 pi over 6. And 5 pi over 6 is the same height as 1 pi over 6. All right, at the halfway point here, 180 degrees, we're just going to label that as pi. Moving down here into the third quadrant, the next position here is 7 pi over 6. 7 pi over 6 is in the same position vertically as the 5 pi over 6. We still have a connection there. The next one we are doing here is 5 pi over 4. That's in the same vertical line as 3 pi over 4. And then the next one we have over here is 4 pi over 3, and notice how that's vertically lined up with 2 pi over 3. All right, at the bottom of our circle here, we have 3 pi over 2. And then we're going to finish up by moving into the fourth quadrant. So the first, next angle we're labeling here is 5 pi over 3. That's the same depth down below as the 4 pi over 3. Then we have 7 pi over 4. That one is lined up with 5 pi over 4. And then the last one we have is 11 pi over 6, and that one is lined up with 7 pi over 6. So the nice thing about looking at these angles now that are measured in radians, all of the angles that have the same denominator, like I'm just going to highlight the pi over 6 family. The pi over 6 family of angles, they all have essentially the same x and y values. The x value is always some version of square root 3 over 2, positive or negative. The y value is always some version of 1/2. And that will be true for each set. All the angles that have a denominator of 4 have something in common with the x and y values, same with all the angles that have a denominator of 3. So adding in our angle measures in radians is something that we are going to start to practice with our circles. So part of the assignment for tonight, I put a pink blank circle up here. I'm going to have you do some memorization practice again, so spend a little bit of time studying your field in the circle. And then your goal eventually is to be able to label all of the angles in degrees, in radians, and all of the XY ordered pairs. We are just going to finish up with one last thing. The final thing that I'd like to show you today is a very easy process that you can follow to convert an angle measure from degrees to radians, or to go from radians to degrees. So now that we know that radians exist, we've seen some examples of what it looks like, we're going to finish up by seeing how we can go back and forth. In our check for understanding, we'll look at a couple of examples, seeing how we can go each direction. All right, so in our quick note section here, we're just going to start with how to convert degrees to radians. Now, depending on the angle that you are being asked about, if it is a unit circle angle that we have on here, like if I say turn 150 degrees into radians, you might just be able to look at that position and say, oh, it's 5 pi over 6. So that's an option. But I might give you something like 72 degrees. Well, that's not on a unit circle. How could we figure out how many radians that is? So what you're going to do is you're going to take your value that you have for degrees, and you are going to multiply it by the fraction pi over 180 degrees. That's how we can go from degrees to radians. And when we multiply by pi over 180, pi radians is the same as 180 degrees. So it's kind of like we're multiplying by a form of 1, where the numerator and denominator are actually the same thing. It's just going to convert it into another form. Let me show you one quick example, and then we'll look at the others. So let's just look at part A of number 2. We're going to turn 54 degrees into radians. So I'm going to multiply this by the fraction pi over 180. Now, what I'd like you to think about here with that 54 degrees in front is write it as 54 degrees over 1 so that we can see it as a fraction being multiplied by another fraction. The way to know that we have the fraction part in blue set up correct is because I want you to think about the degree symbol canceling. Think about canceling that degree symbol from the top with the degree symbol that you see on the bottom. Then what we do is we multiply across the numerators and we multiply across the denominators. So essentially it's 54 pi over 180. But then I want to see if I can reduce this down. So I'm noticing that both 54 and 180 are even numbers. So if I were to divide both the numerator and denominator by 2, I'm just going to see where that gets me. We might be able to go further, but that's going to get us to be 27 pi over 90. Looking at the 90 and looking at the 27, I'm thinking, okay, I can actually divide both the top and bottom by 9. So I'm going to go one step further. 27 divided by 9 is 3. I'm still going to keep the pi after that. 90 divided by 9 is 10. So I always want to get a simplified fraction, simplifying this down as far as I can go. Now, the example that we did here is of a positive angle. So our answer in radians is still positive. But notice, like, if you were to do one, like in the assignment tonight, where the initial angle that they give you is negative, then your answer would just also be negative. All right, so that's how we can convert from degrees to radians. By the way, if I were to try to draw a sketch of where 3 pi over 10 radians would be, all I would need to think about is the top half of my circle is pi radians, and because the denominator is 10, I would divide it into 10 sections. So there's 5 sections on the left. I'm going to do 5 slivers on the right. Now, even though this wasn't a standard one on the unit circle, that's fine. You can still do the same thing. So this would be 1 pi over 10, 2 pi over 10, 3 pi over 10, and so on. So that's how you can think about, like, what if I have a different kind of denominator? All right, let's go back. We're just going to finish up with one last example for how we can go the other direction. So what if we want to convert an angle in radians to degrees? This one is very simple, so we're going to start with our angle measure in radians, and we're just going to do the opposite. So this time we're going to multiply by the conversion factor, 180 degrees over pi. All right, and let's just look at one example here of going the other direction. So let's just look at number 1 here. So let's say that I wanted to do 3 pi over 5. That's also not a standard one on my circle, which is fine, but I can use my conversion factor of multiplying it by 180 degrees over pi. The way that I know I'm doing the correct conversion factor is because I'm always thinking about what I'm canceling. So this pi on the numerator with that pi on the denominator, kind of like how the degree symbol canceled out before. Pi is not a symbol for radians, but the pi's will cancel on the top and bottom. And so then I'm going to multiply across the top, so I'm going to do 3 times 180, and that gives me 540 degrees. When I multiply across the bottom, it's really like 5 times 1, so it's just 5. And then I'm going to continue going, so 540 divided by 5 gives me a final answer of 100.